Thank you, Francesca. And hi, Product Lab. How's it going? How's everyone doing? All right. Quick introduction. My name is Mirza. I'm leading the team of product people that are building the AI agents platform at Zendesk. So that means that we're living, breathing AI, dealing with a lot of the issues that you heard from previous speakers, and building agentic systems, building autonomous agents, and making sure that what we're delivering is actually creating value and improving business outcomes. That it's not all just fuzzy AI fluff. In my spare time, I also spend some time writing a newsletter for aspiring product leaders. So if you're interested in breaking into AI, you are the product.io. If you can also find out more about me at mirza.tech. Um, I want to talk a little bit about how the PM job is changing. I think most PMs don't realize that the product management job has already changed drastically and fundamentally. We're all still kind of catching up with it. And what has specifically changed is the introduction of agents into our lives, into our roles, into our day-to-day. What is an AI agent? You hear this thrown around a lot. You hear autonomous agents, you hear AI agents, LLM workflows, LLM wrappers. What's the difference? So in the simplest of terms, an AI agent is a goal-oriented system that can reason and act with autonomy. It can plan, it can act, it can loop. It has dynamic decision-making ability, which means that it can use a variety of tools and apply reasoning in how it uses those tools in order to solve a problem. So Francesca's trip booking is an example of that, where an agent would then have to reason through a lot of steps and decisions and then use various tools, booking systems, platforms, etc. Lastly, an AI agent can adapt in real time to changing context and user needs. A user can switch language. A user can change the conversation into a completely different direction. Just like a human would be able to, an AI agent can adapt to that and reason over the interaction and then modify its response. Now, we often also talk about agentic systems. What is agentic about all of this? So again, in very high level terms, agentic is the workflow in which AI acts with autonomy, in which AI agents or autonomous agents interact with each other, plan, make decisions, use tools, and adapt dynamically. Now, I wanted to start off with the definition because I know there's, we throw this word around a lot, these expressions, because I want to ask you before we go on, raise your hand if you've built an AI agent in the past 6 months. All right, quite a few. Now keep it up if it actually worked the way you wanted it to work. All right, that's about half. All right, now keep it up if you're still using it 6 months later. All right, that's about 10% of the hands that were up. And you're not alone. This is not a representative study by any means. This is me on LinkedIn asking my friends, but 75 of them in product are basically in the same area. About a fifth or fourth deployed an AI agent. Most people haven't, or a lot of people haven't used AI agents. Some are still learning and experimenting. Most are still learning and experimenting. We're all in the same boat here. Most of us are still learning and figuring out how this is working. It's no different in enterprise. The promise is agents will come in, take over, they're going to run the show. The reality is different. Agents mess up, handovers fail between agents, latency is a massive problem. So we're still facing a lot of the same issues, both privately and in the corporate context, and we're all still learning together. And conferences and events like these are opportunities for us to exchange and talk about these experiences. Now, I want to talk about, there's a transformation that's happening in product management, and there's what I see as 3 fundamental tensions emerging that are breaking everything we know about product management because of the introduction of AI agents and agentic systems. One of them is what I call the control paradox. Users tell us they want control. They want to be able to train the bot, They want to be part of how the system behaves, but they don't want any complexity. They don't actually want to have to go into the nitty gritty of it all. The other is the orchestration trap, where more specialization, smaller agents that have a smaller scope perform better, but that means you have more agents that you have to orchestrate, that you have to coordinate. This creates a lot of chaos in every sense of the word, in engineering terms, in architectural terms, in just product development terms. And then lastly, there's an evolution crisis. Our teams and our tools are starting to break and buckle under the pressure of this paradigm shift. We're all kind of learning as we go. We're, as the famous saying goes, building the plane while flying it. And it's causing an impact on product development teams. Now, if we go into this a little bit, the control paradox. Users want to train the AI, but they don't really want to know how it works. They don't really want to invest the work. At Zendesk, we do customer service, so I have a lot of customer service examples. You can create. We offer users what we call instructions. They're little bits you can inject into the behavior of the system, and we often get users saying things like, when a customer is saying X, always escalate to a human agent. That's one instruction. And then in the instruction right below it, they'll write, but resolve everything autonomously. So this is a very human example, because you want control without understanding how these two things can interact, what the contradiction in these statements are. Now, this is a very banal example that I chose. There's many much more profound and more complex examples. But the problem with this is that, this kind of individual feedback from, let's say, a human supervisor that doesn't have a full understanding of a larger system creates local problems, and creates local conflicts and contradictions. Because at the end of the day, most users want the illusion of control, not actual system effectiveness. So how to solve for this? It's not more control panels. It's not more actually creating more opportunities for users to mimic control. It's about designing touch points that preserve their agency without breaking the underlying system. Now, what does that mean? This could be something like binary signals. We need the user to validate something that the AI system created and produced, because human judgment is still the best. We can create layers. I think we heard it earlier. We can create evaluation layers where not every piece of feedback that we're getting from a human counterpart should modify the behavior of the system. We should figure out how the feedback fits into the larger system. The other approach that we're taking, that a lot of people are taking, is architecting kind of a 3-layered system. One, aggregating analytics so that users can understand the big picture of what the system is doing. But also offering drill down so they can go into the specifics. Now, again, I'm a little bit biased thinking about it from a customer service example, but when we're automating customer interactions, they want to know what's happening as a whole, at large, and then they want to be able to drill down into individual conversations. And then there are many opportunities in there where we can get human judgment to tell us this was a good response, this was a bad response, et cetera, et cetera. And then lastly, opportunities for qualitative feedback. Now, all of you product people, user researchers, etc., same thing, just applied to an AI system. We want feedback that has conflict detection so we can prevent contradictions and passing contradictions onto the system that we're building. Moving on to the orchestration problem, specialized agents perform better. But every specialization means that the complexity is higher and higher. Now, more handoffs between agents means more latency. It means things get slower. And if you've ever talked to a chatbot and waited for 10, 15, 20 or more seconds to get a response, you know what I'm talking about. And humans are very, very sensitive about this, because we as humans, when we interact, we have very low latency. So that we're expecting the same from our AI systems. The other thing is more agents means more failure points. You're creating a more complex system, handovers will fail, something will fail. And when one agent updates or fails, the ripple effects can be unpredictable because the more complex the system is, the more difficult it can be to track down what happened and why. We heard this also earlier. I thought it was impressive what Rose is doing, on a weekly basis. It's a little harder in larger systems on an enterprise scale. Because of we have business customers, so any change we're making can have a downstream impact. So we have to be very careful about what we're doing to model updates, and we have to be very critical about it. But even for us, it means we're essentially rebuilding everything every 3 months. This is the last, what is this, 2022 to today, the growth and expansion of different foundation models. Your prompts break. When the model updates, the old ones sometimes start degrading. There's model drift. Your entire product behavior can change if you just switch without adapting your prompts, without adapting your system. Performance can shift and change. And you're faced with the challenge of building a stable system on fundamentally unstable foundations that are ever changing. But with all of this, these are challenges that we haven't all solved. We're figuring it out. There's a lot of approaches with dynamic prompting. With I think Enrique talked a little bit about how Rose is approaching some of these challenges. We're not fully there yet. We're still figuring it out. But, and this is where the PM role is really changing. We are already in a world where we're creating not just product interfaces for humans to interact across. We're creating digital workspaces for AI agents to collaborate with one another. Now, most of us are still building agents within closed systems. So we're building a network of autonomous agents that are interacting to solve a problem. We're obviously moving in the direction where Web 4.0 is becoming, and hopefully will become, more interoperable, so that your autonomous agent can talk to my autonomous agent, and your company's autonomous agents can talk to my company's autonomous agents to solve human problems. Think Second Life, but agentic. Digital workspaces where these agents kind of live and exist and have roles and have functions, specialized capabilities, and a clear purpose, where they can invoke tools autonomously. What this means, we use this for tools a lot. We're usually talking about third-party systems, API integrations, etc. But they have the ability to talk to each other and interact. You're seeing a lot of this through stuff like MCP and agent-to-agent protocols. It's slowly happening. We're slowly getting there, and we're moving in that direction. But most importantly, we're building an environment where agents can pass context between each other in order to solve human problems. Lastly, the evolution crisis that I mentioned earlier, how this is affecting our teams. Now, teams are starting to split a little bit along teams that work with AI and teams that don't work with AI, where teams that are working with AI are seeing that some of the traditional planning methods are failing. Or they need to be adapted. AI research cycles are not the same as typical product planning. For AI research, things can take 6 days, they can take 6 months. It depends. This is the nature of probabilistic systems that don't correspond to deterministic PRDs. You can't just write an upfront spec. I mean, you never should have been writing an upfront spec anyway to begin with in any system, but now you really can't with an AI system, which means the teams are starting to fragment across these lines into AI versus quote unquote traditional, which, poor word choice on my part. I shouldn't call them traditional. They're still here. They're modern. They're contemporary. So the question is, should agent teams or teams building agentic products stop building user-facing features? That's a tricky question to answer. Should autonomous agents be building the features instead? And what does that future look like? I'm not here with an answer. I'm just poking and provoking from this stage today, asking this question. Because the change and the shift is which again, I think is a good evolution. It always should have been this way. Planning is just hypothesis testing. We're talking about bets and experiments. And we've been talking about this before AI, but it's easier to get away with it in, quote unquote, the traditional approach to product development. What's happening with PM teams and product teams is that we're slowly evolving from being feature builders or only feature builders to also being orchestrators of how humans and machines are collaborating and working together, how we're deploying agents to solve human problems and solve for business outcomes. Now, PRDs, never liked them to begin with. Not sure anyone ever has. There's talk about using prototypes instead. So you're showing and not telling. And I just had a discussion downstairs about this, about vibe coding and where we stand on vibe coding. And look, I don't think that every PM needs to be vibe coding, but I think every designer should. And designers who don't are at risk. Feature specs are evolving and at least being expanded to add context architecture. This is your context engineering, your prompts, your everything that goes into how an AI agent interacts and exists within a system. User stories or jobs to be done stories or job stories are now supplemented or complemented by agent instructions and what an agent is supposed to do in a system. Product planning, again, with research cycles, launch planning with approaches to continuous orchestration so that you can figure out how agents interact and evolve and collaborate. And your Marty Kagan experience teams become capability teams. A bit of both. Now, are product teams going to stop building customer-facing features and UIs? No. Are they going to start leveraging autonomous agents to help them build those? I think so. And I'm willing to die on that hill. And a new PM job, writing evals. If you've been on LinkedIn in the last 6 months, you've seen the word evals. Evals are frameworks that help you measure the performance of an AI system, metrics, scorers, evaluation data sets. And it's something that is not just a PM job, it's an everybody job in a world where we're building AI systems, but PMs need to get good at evals. And I'm not going to bang on this drum because you read it every day on LinkedIn and there's enough people talking about it there. But yeah, invest in evals. PMs who, in my opinion, will thrive in this world are builders and orchestrators. Again, we just had this discussion downstairs. Does everybody need to become an IC and technical and a builder? No. We still need strategy. We still need market understanding. We need all the classic responsibilities of product management for the job. These don't go away. As a matter of fact, they become critical because for all its capability, AI systems can't replace human judgment. I hope. So yes, but my advice is, experiment, play around, experiment personally, and find opportunities to architect at scale through work or other areas. This is what will set you up for success. The PM toolkit then, is somewhere in between here. This is the new reality. An agentic PM is part builder, part orchestrator. Somebody who perhaps creates agents for themselves, who documents what is breaking and why in order to learn, sharing their learnings publicly. And I'm trying to give you a roadmap or a blueprint as to how to break into an AI PM role. This is it. If you don't have the AI job, just do this. Create social proof. Start talking about it online. Experiment. And, figure out how to design agent interaction patterns. Figure out what that even means, because it sounds very fuzzy and fluffy. But until you start chaining agents in a flow and seeing it break, this is where you start learning about agent interaction patterns. Figure out how to architect human touch points. So do personal examples. A colleague of mine who's sitting in the front row told me about how she's vibe coding something for her child, to use for a specific problem that the child has. There's your human touch point. Think of how to integrate, quote unquote, the human in the loop into the experiment you're building. And then create transparency around it. This is one of the big challenges also in a corporate setting. AI is still a black box to most people. So creating transparency and explainability into your product, building that into your product so that you're exposing the chain of thought, so that you're exposing how the system is resolving a problem. That's incredibly valuable. That's where, that control illusion is actually what it's actually all about. People just want to understand how the system is performing and why it's doing something. It's a trust building exercise. And yeah, build evals. Learn how to build evals. The one skill that I promise you everyone will be testing for or asking you about in your job interviews in the next year or so will be about evals. So learn evals. None of us have all this figured out, but community is the competitive advantage that we as product people have. These kind of forums where we can exchange and talk about this stuff. So the question isn't whether you'll become an orchestrator, it's whether you'll do it intentionally and learn on the journey. So my advice this week, try to build an agent. Use anything, N8N, Zapier, whatever. There's so many tools out there. Ask ChatGPT. Map one of your workflow, whether it's a personal one or something you do at work, and try to do it as an agent interaction. You see people doing it for their emails. Try to do something that's actually useful to you. And figure out one human touch point where you could simplify. And for the rest of the month, try to prototype instead of writing a PRD. Try to run a research cycle instead of running a sprint. And share your learnings publicly. That's my advice. And that's my spiel. Thank you.
Thank you, Mirza. Amazing advice. And I think what fascinated me the most about how we human think about the agents. We want them to be automated, but and not caring about what's happening behind the scenes. So we want just them to happen. And what does it mean for us PM that have to put the two together? But we have time for questions now. So here already we have a hand. Thank you.
Thank you, Mirza, for the wonderful talk. Very motivational besides being useful. My question is about the evaluation layer from customer feedback when you have the thumbs up and thumbs down feedback, especially because Enrique said that for their use case, they don't find this customer feedback useful because it's very isolated, but you find it useful and you create evaluation layers. So if you could share, how do you create those evaluation layers?
I'll admit that in the beginning, we didn't find it useful either. As an individual signal, but where we realized it is useful is if you sprinkle it in a sea of other signals and connect it into a larger whole. So what we started doing is we started giving admins in our system the ability to review customer service interactions and tell us this was a good interaction, this was a bad interaction, because it was done by an AI agent, versus an end user telling us this was the right response, this was the wrong response, which then goes kind of into CSAT and customer satisfaction measurement. And then other areas where we're sprinkling opportunities to get human feedback and human evaluation. In isolation, just thumbs up, thumbs down, that's not enough. We in the beginning tried that. We realized most humans don't want to give you thumbs up, thumbs down. When's the last time you actually did that on a ChatGPT message or any other message? So we weren't able to get statistically significant volumes of data. But when we kind of expanded what we were collecting and we started incentivizing users to give us this feedback, that's when it started working. So it's about a larger whole, more signals than just one, and figuring out how to incentivize users to give you that feedback.
Thank you. And how do you incentivize users to give the feedback?
Well, if you're a customer service team manager and you're reviewing how your AI agent is solving conversations, you're very incentivized because you're paying for it. And we charge per successful resolution. So our customers only pay if we successfully resolve what the user was asking. So of course they're going in and checking, are these resolutions actually worth the money they're paying for? And there's your incentive. So it's about creating this kind of closed loop, if you will.
Thank you, Mirza.
So probably thinking about who are you asking the thumbs up, thumbs down. So if it's like it's something in it for them, then it's a good target group. If it's nothing in it for them, that is not a good target
Who
group.
are you asking? Where are you asking? And when are you asking? Yeah.
There is a question.
Yeah, thanks for the talk. So my question is, because I have a very shallow understanding of the software landscape for agents, for agentic workflows, for agent orchestration so far, what are some, maybe a brief overview from your side, what tools you find very helpful, which software you find really helpful for doing these things, and also where you strategically decided to build your own solutions at Zendesk.
I think there's a big difference between kind of personal use and doing it in a business setting, because the tools change. The underlying models are maybe similar because unless you're like Rose experimenting with a lot of open source stuff, you're probably using one of the big foundation models that OpenAI is offering, or Anthropic, or Google. But there's a lot of applications that exist on top. So I don't think it needs to be over-engineered. I think you can learn a lot just by interacting with ChatGPT and Claude as a step one. Step two, I think Zapier really is, and it's evolving into a very helpful tool and a very helpful platform where you can build workflows, chain agents. There's a debate about how much of this is actually agentic or not, but I think it's a good area to learn and space to learn. If you're a little bit more techie, N8N also has some stuff that's available for free, even though they're technically a B2B business, but they have some stuff that's available for free that you can experiment on your own. And then honestly, there's a sea of other providers out there that are offering things like Relay or Lindy or Flowwise. Some of them are more, they come with a cost. Yeah, I don't know if that's answering your question. There's that's where I would start. That's where I would start. I would also try to figure out what it is that you're trying to solve. If you're trying to build a website, you don't necessarily need to do that with an agent. So it really depends on what you want to solve for.
Okay, thanks.
Any other question? There. Ooh, let's see, from a speaker to a speaker. That's like it going up.
Okay, like this really zooms into one very specific aspect, right? But you've mentioned the smaller the agents, the more the number of agents, and the larger the agents, the less the performance. This is something we've been struggling with as well. How are you finding the balance?
How am I doing what?
The balance between how task-specific an agent is and how generalized you want to keep it.
Yeah, that's a rough question. No, I mean, like we're also still figuring it out. I think I'm not gonna say we solved the orchestration. We haven't. I think we're experimenting on different scales. So like so our system currently, we started with, I think 3 is where we started. We're now at 15, roughly.
Nice.
Autonomous agents in a larger workflow that are interacting. And it started with very simple things, like one was just a RAG agent, one was an intent classification agent, one was a whatever. And now they go to such specificity that the names of the agents don't even translate anymore to humans, because they're doing really tiny specific things. I don't have an answer for you. I don't think there's one balance. I'm learning that you can't just have one orchestrator. I'm learning that it kind of like if you think about it as the Spotify model with product tribes, think of agents as product teams. You have a big org, you have these larger domains, and in each domain there's a group of teams. So that's kind of how we're thinking about it with agents. There's a large org, there's domains, there's agents, and each of those domains requires its own generalist and own orchestrator, and then the entire network requires an orchestrator on top. But this doesn't always work. This sounds very clean cut and easy. It doesn't always work. Sometimes they don't belong in the domain. Sometimes they kind of need to come in and out, etc. So yeah, I don't really have a good answer. I can tell you that the pain is real and that we're all feeling it.
That is honestly a very good answer. Thank you.
You're not alone, Pranav. So that was like the answer. You're not alone.
You're not alone, for sure. There's a world full of agents.
Any other question? Then yeah, there. Thank you.
Thank you. Hi, I was curious about the evaluation layers that you mentioned, especially when we are dealing with the customers, like in the customer support area, where customers might come already with some like frustration because they cannot like solve something or like. So how do you deal with this like frustration? I think you mentioned like the thumbs up and everything, but I was just more curious about this like, you know, continuous evaluation and making the model to like just adapt and like reduce this frustration when customers are talking to an agent and not like a real person.
Well, I mean, there's kind of two sides to this. There's one, you know, there's end users interacting with the chatbot and being frustrated because they want to solve a problem. And there's the system itself that's coming in to try to solve that problem. Where we build evaluation layers is more on the system side. So we're building scorers that as a question is processed through an agentic pipeline or a pipeline of our system, I'm trying to kind of simplify it a little bit. Like we're trying to like hit different stage gates and quality gates and make sure that what we responded with actually solved the problem in a measurable way. And again, I'm not explaining this very well, but evaluation layers exist to tell us whether our system is failing. It exists to tell us to also log behavior of the system so we can figure out, you know, the bot responded to a customer and it hallucinated the answer. The answer is completely wrong. How do you know it hallucinated? So one way is obviously the user telling you this is a hallucination, but how do you do that at scale? When, you know, you have millions of conversations in a day, how do you know which ones were hallucinated and which ones aren't? Not a problem that, despite what OpenAI tells you, has been solved. Hasn't been solved yet. They claim they have a solution and that it's going to take 12 months to get to it, but I'm a bit skeptical about it. So the evaluation exists for us to at least try to detect that something was a hallucination or went wrong in whatever way and find a way to quantify that so we can look for patterns at scale. This is what this is about, effectively. On the flip side, you know, the users giving us validation as an extra signal of quality. You can think of it more as like QA or quality control. They work hand in hand. They're not the same thing. I hope I'm making sense. This was a very roundabout answer to your question.
Thank you.
We have time for another question if anyone has. Oh, we have two, but she was first. Just repeating the question, what are some of the quality gates that you're looking at right now in your customer service?
Sure. So in our Agentic product, one of the ways in which we handle an interaction is through what we call procedures. So the system can detect an intent. So the user asks a question, we detect the intent of the question, and then we have in our system an admin can write text, even just a list of bullet points saying the user is asking about order cancellation. And the admin can write a procedure that says, okay, if the user asks about order cancellation, then do A, B, C, D, E. And it's just very high level. And from that, we generate a whole execution flow and model for how the system should behave. Meaning that the admin can say something like, if they're asking about order cancellation, look up the status of the order in the order system. And that's it. They don't have to do much more than that. The system then figures out what is the order system, how do I look it up, yada, yada. One of the quality gates in this example is we want to know where, so these procedures are then kind of broken up into steps. We want to know, was every step completed? So we have a metric we call procedure completion rate or step procedure rate. So that's one of the, for example, the quality gates. Just your basic stuff like, did the system actually do what it's designed to do? And in this case, because this is to execute on this procedure, it's actually 2 or 3 different agents more that have to interact in order to solve this. One agent has to check the knowledge base to see if there's any information about order cancellations. Another agent has to, invoke a tool and send a call via an API to a system to retrieve data. Another agent, the first agent has to detect the intent and then pass all this content. So they're passing context. So another quality gate is, was the context passed? Did the agent handoff work? Was the response generated? We have an evaluation or a validation layer where we evaluate was the response that we generated high quality. And then lastly, after the entire interaction is completed, we also, there's an LLM as judge, if you will, that's checking if the entire conversation was a successful resolution. So we have all these different steps where we're trying to figure out, did the system do what it's designed to do? Did it do it at a certain quality level? And, did it do it fast enough? Because in all of these systems, the number one problem we all have is latency, latency, latency. Again, humans have very low latency, and AI agents don't.
Thank you, Mirza.